In this tutorial, you will create a two-story wood frame structure with a one-story garage and design it for automatically generated wind and seismic loads. To start, define the initial settings and preferences for your project by going into the Settings menu. In the Settings window, you can insert the company information, project description, For a detailed look at the settings in Shearwalls, please look at the video called Design Settings. For this example, in the View tab, set the snap increment to 6 inches, and make sure that the Fit View to Area window and Fit Building to View area are unchecked. Set the Display Grid Lines to Off. In the Design tab, click on the Reset Original Settings and select the ASC 7 directional method for all heights if this is not the case. We are now going to import a CAD file by clicking on the Import CAD button. Set the number of levels to 2. Click on the Import File. In your Shearwalls directory, there should be a file named Example. Open the file. We are going to import the same file for the second level, but please note that it is possible to import different files for its separate levels. We will now position the floors for the first level by clicking on the bottom left corner. Set the coordinates. Next, select the bottom right corner and specify a distance of 20 feet. The same steps are repeated for the second floor. We now have a layout as a background, so we can design our structure accordingly. Select the structures icon and lay out the first block. In the field called block name, type in main. Set the number of levels to 2. Now we will create the second block and call this garage. Set the number of levels to 1 and the foundation elevation to 3. Notice that the foundation elevation also changed for the block main. We will now insert the walls. Select wall 4-1 and separate it into 3 different segments. Next, hold down Shift and select wall 4-2 to extend it. In order to limit the unknowns, we will choose the following properties for all exterior segmented walls. We can now draw interior shear walls, which may or may not be required depending upon the magnitude of the loads. However, it is important to note that the software can only manage one type of shear wall along a shear line due to material compatibilities. For example, if we were to draw an interior shear wall between segments B1 and B2, the renamed segments B1 and B3 would now have the properties of segment B2 once the calculations are performed. Therefore, for this example, segment B2 will be kept as an interior non-shear wall. It is also important to note that by default, the program does not account for the weight of non-shear walls in the seismic weight, and that if it needs to be accounted, it should be added manually or accounted through the floor dead load. Typically, all interior walls would be drawn and designed as non-interior shear walls. For this example, only a few non-shear walls will be drawn. Next, select the Openings button and create a garage door by selecting wall 3-1 and clicking and dragging across it. Make sure that your offset from the edge is 3 feet, the width 14, offset from bottom 0, and height 6.75. Continue to place door and windows opening around the structure as desired. To ease viewing, click on the Import CAD Drawing button and the layout will disappear. You can turn it back on at any point during the design. Click on the Extend Walls button. This automatically creates the upper level walls for the blocks with multiple levels. To view the current openings, click on wall E1 and select the Elevation View button. To add a roof to both blocks, click on the Roof Blocks button and roof blocks will automatically be assigned to each structure. Select the main block and set the east and west slopes at 30 degrees, along with the overhangs to 2 feet. Set the ridge direction to north-south and the east-west slope to 30 degrees while setting the overhangs to 2 feet. Before generating loads, click on the Site Information button. Here you can set the parameters that will be used to generate the wind and seismic loads. Now close this window and click on the Generate Loads button. Select wind and seismic loads to be generated from levels 1 to 2. Click on the Generate Loads on selected level. This automatically creates loads. You can view seismic loads by going to Show and Seismic. You can also view level 1 seismic loads or wind load. Click on the Loads and Forces button. Select wall A1 on level 1. These loads can be modified or deleted at this stage based on your judgment. Loads can also be added. Click on the button Add. Select Seismic Line Load. Apply to selected walls with a magnitude of 10 pounds per linear foot. To view the various forces and loads, use the Show menu in the input form. Now only the seismic load applied to wall A1 will be shown. Now click on the Design button to run the program. Return to the Loads and Forces view and select Show, Forces, and Rigid. This will show you the Rigid Analysis Force Distribution. To learn more about rigid and flexible diaphragms, please view the video called Flexible and Rigid Diaphragm Distribution. Looking at the walls, it can be seen that shear lines B and E are highlighted in red, indicating that the walls have failed. This is also indicated at the bottom of the viewing area. Furthermore, when selecting the flexible force distribution, it can be seen that the walls along shear line 4 also fails. A failure of a wall is also indicated in the elevation view. In addition to seeing the word failed, the shear forces, hold down forces, and drag strut forces are shown. By going to Show, Forces, Hold Downs, and Separate, you can view the hold down forces broken up by its component. It is important to note that if both levels are shown in the elevation view at the same time, that even though the wall has failed, it will not be displayed. The results from the analysis can also be seen in the Results section, where it is easier to see which wall failed. By going to Go to Table, Wind Design, Flexible Diaphragm Design, and Shear Results, it can be seen that walls in shear line B and E fail. By looking at other tables, it can also be seen that more walls fail under different circumstances. In addition to the shear walls failing in both wind and shear design, it can be seen that the capacity of some hold downs is exceeded. To remediate to this situation, the properties of the wall will be changed by going back to the Walls view. Since the Design and Group option is selected for the exterior segmented walls, applying the change to one wall will apply it to the rest of the exterior segmented walls. We will increase the sheathing thickness and reduce the nail spacing for both edge and field. Notice that the change has been applied to the other walls, as well as the walls from the second level. In some cases, the user might find this too conservative, therefore the Design and Group option should be unchecked and the wall properties change individually. Since the hold downs at some location failed, we will choose an appropriate hold down and rerun the design. Contrary to the walls, the hold down needs to be changed on an individual basis, or by selecting all walls. It is not affected by the Design and Group options. Be careful when selecting all walls at once, as only the exterior segmented walls are needed. By holding down the Control key and deselecting the interior non-shear walls, we can then apply the right hold down. We will now rerun a design. And as it can be seen, no walls failed either on the first or second floor. The results will show the details. It can be seen that the shear walls do not fail, neither does the hold down, for both the wind and seismic cases. The remainder of the results, which includes the project information, structural data, and the loads, can be seen using the Go to Table data bar. This concludes the end of the advanced tutorial.